All right, so Benedict solution, which uses copper +1 to oxidize aldehydes into carboxylic acids and get us back to copper 2. This is used for the test for the presence of saccharides. Now, aldoses, this is really easy. If we have an aldose, there's no group here, and we directly oxidize the aldose to the carboxylic acid, and this is how the Benedict test proves that you have aldose. But how is it that without an aldehyde, we're still able to get to, like Benedict solution will still react with ketoses? This is actually kind of a weird, I see why it works, I just think it's kind of weird. Basically, we get two tautomerizations that go on. So if you go back to the videos on enols and enolates, your aldehydes can tautomerize into a ketone. And so particularly in the presence of water, we have this two-step process. We have the oxygen grabbing a hydrogen, and this will give us the hydroxide. And this kind of like a, what am I drawing for? H3O plus, whatever that's called. It's really embarrassing, I can't remember that right now. This complex. We'll end up getting the hydroxide, abstracting a hydrogen off of this carbon, and that'll kick down, that'll kick up, and what we end up getting is a double enol. And so that's the first step of this mechanism, is that we get tautomerization to give us this dienol complex. What happens next is that we just get tautomerization again, but instead of going back to this compound, our starting ketose, what we end up getting is tautomerization. So we have water, and our water will abstract a hydrogen. Well, basically through the reverse of this mechanism, we'll end up getting this complex here. So in order to justify why a ketose would still react with Benedict's reagent, we basically see double keto-enol tautomerization. The first one takes our ketose and converts it to a dienol, and then the second one converts our terminal alcohol into this aldehyde, which then reacts with the copper +1 to form copper +2 and the carboxylic acid. So this here is how we're able to justify why Benedict's reagent will still react with both aldoses and ketoses, even though your ketose doesn't actually have an aldehyde functionality on it.